more on sorting considerations. So we want to look at testing it, look at efficiency of it, and discussing a special concern involving with sorting objects rather than primitive types, and considering the stability of sorting algorithms. So testing. To thoroughly test our sorting method, we should vary the size of the array, vary the original order of the array, random order, reverse order, in order, almost sorted, all identical elements to see efficiency of each. When n is small, the simple sort may be more efficient than the fast sort because they require less overhead. Sometimes it may be desirable for efficiency considerations to streamline the code as much as possible, even at the expense of readability. For instance, instead of using a swap method, directly code the swap operation within the sorting method. So, special concern when sorting objects. When sorting an array of objects, we are manipulating references to the object and not the object themselves. So before sorting and after sorting, we just change the reference to the object. So we use comparable interface. For our sorted lists, binary search trees, and priority queues, we used objects that implemented comparable interface. The only requirement for a comparable object is that it provides a compare to operation. Limitation of this approach is that a class can only have one compare to method. What if we have a class of objects, for example student records, that we want to sort in many various ways, by name, by grade, by zip code, increasing order, decreasing order? In this case, we need to use the next approach, comparator interface. So I once discussed about this right from the previous video, you can review. So let's revise again. So comparator interface provides another interface related to comparing objects. So define two abstract methods, compare, like object 1 to object 2, return negative integers 0 or positive, indicate O1 less than, when it's negative, equals, when it's equals zeros, right? Greater than, when it's positive, or when it's greater than O2. So, and another one is equals, right? Return either true or false. Comparator interface, if we pass a comparator object comp to a sorting method as a parameter, the method can use comp.compare to determine the relative order of two objects and base its sort on the relative order. Passing a different comparator object results in a different sorting order. Now with a single sorting method, we can produce many different sort orders. Right, because we compare object to object now, right? We didn't compare the primitive types in like compare to. Right, compare to determine the relative order of two objects and base its sort on that relative order. Different comparator objects result in different sorting order. With a single sorting method, we can produce many different sort orders. Look at example. To allow us to concentrate on the topic, right, we use simple circle class. So sort circle, x values, y values, and radius, boolean solid. And comparator object that orders sort circles based on the x value. So we implement comparator xcom equals to new comparator. We have the method compare passing sort circle A and sort circle B in. Right, so a.x value minus b.x value. It's going to return either negative, positive, or 0. Here's selection sort method along with its helpers method min index. Alright, so min index, start index, end index, and now we pass the comparator sort circle we call comp. So we iterate to the list. If we compare object, right, comp.compare, we compare two, right, values index, two object at each index. We see if it's less than 0, then we have the new index. And selection sort method takes the comp as the sort circle, comparator, and we just loop through it, right? This is the selection sort itself. We just take the circles, iterate to it, pass the comp here as an object. Now look at stability of a sorting algorithms. Stable sort a sorting algorithm that preserves the order of duplicates. So of the sort that we have discussed in this book, only heap sort and quick sort are inherently unstable. So in heap sort, it's not preserve the order of the duplicates. When we have the duplicates, it's not really care. It's only care about parent has to be greater than the child. As long as child can be anywhere that's less than, is fine. And quick sort we said is depending on the split values. So it's not even care about the order of the duplicates. So searching, in this section we look at some of the basic search by value. So we already learned how to sort now. This is about searching.